right? And then we talked about the properties here, yeah. Law A, about the properties of electrode. We talked about these two pieces. We place these two pieces in the container. What you know about the properties of electrodes, Law A?
They are unreactive.
Okay. The most important point is what? Yes, unreactive or inert, it is one important point. What is the next one? Or the first one, in fact?
They are conductors of electricity.
Yes, very good, Yellow Eye. And we have another point. They have high melting point. So good conductor of electricity, because we will see a movement of electron from the anode area toward the cathode area. And also they have very good, Yarim, they have high melting point. With the material, we said a material suitable to use it as electrolyte, either you write down carbon or graphite only. That is regarding a non-metal. For a metal, we choose inert. Very good, inert. Yes, platinum or titanium. Platinum or titanium, sorry, not nickel, sorry. It's platinum and titanium. Why we choose these two metals? Because they are unreactive, as I said. So titanium or platinum. So please, if they ask you to choose metal as electrode, don't choose any other metal like sodium or magnesium or even iron. We are talking here about unreactive electrode, unreactive electrode. And then we described here a cell. It is a battery or dry cell. And we have these two pieces of electrodes, and then we connect using wire. What will happen here? Opposite charged particle attract to each other. So I have here whatever particle X plus, it will go through going toward what? الكاثود area. الكاثود, which is a negative terminal. والانود Y negative, it will go toward الانود area. A reason for that, if they ask opposite charged particle attract each other. All right. And then we talked about uses of electrolysis. One of them, that's what we started last time, extraction of metal from its salt. So we'll talk about the electrolyte. Electrolyte, let's remember together what we did last time. I have molten one. We understand now a reason. Okay? And aqueous one. What is the meaning of aqueous here, Muhammad Fahmi? What is the meaning of aqueous? What is the meaning of aqueous? Pay attention. What we know that it's ionic, but the word of aqueous, what's the meaning? Dissolve it in water. Very good. El molten, just we melt sodium chloride, for example. But this one, I dissolve this one in water. With this case, we have 4 ions here compete with each other. That is the last part done last lesson. We will repeat it again. But the molten salt, it is very, very simple. If they give you molten salt, we can get a metal from a molten salt. All right. For example, I have this particle. We have sodium ion and the chloride ion. Always a positive ion, it is metal. We know that from a bonding. Always on the left-hand side. So I need to write down the equation at cathode Yahaya. If I need to write down the equation at cathode, I have a sodium ion will go toward the cathode area. I need to get a product. What we said about the writing the equation. Plus, higher. Yes, plus one. Plus one. Raise your voice higher. I can't hear you. Plus, the value of the charge here, 1. So, plus 1 electron will get sodium metal. What is the observation, ya Salma? Salma Walid. What you see at cathode area. What you notice. Observation, it's a question in your exam. Very good. Salma? Salma Walid, what you see? What's the color? Observation, something you see, something you notice. Color change. What's the color of metal, Salma? What's the color of metal? Gray, very good. So we get gray metal at cathode area. All right. Then what about a chloride ion? We'll do the same way. We do the same way. Salma Sayed, if I have here at anode area, I have Cl minus. Well, if you do the same way, it will be very simple in your exam. How to write down the equation here, Salma? Yes, negative 1 electron. Don't write L1, please. I will get Cl, but the halogen is what? Monoatomic or diatomic? Salma, is there any lagging? Yes, diatomic. So Cl2, and then I never write the value here under the ion. I put in front where every ion loses 1 electron, so it is 2 electrons. If you want to write down like this way, don't worry. You will get a full mark, all right? Or you can write down the electron on the other side. 2 chloride ion will get chlorine plus 2 electrons, all right? They will ask an observation here, the color of chlorine until we revise the periodic table. Very good. It's green bubbles. We get green bubbles. All right. So we get gray metal and the green bubbles. You can write down yellowish green, but green acceptable. That's the right answer. A kind of reaction is what here? The sodium ion gained the electron. The sodium ion gained the electron. What kind of reaction, ya Noor? We have either reduction or oxidation. Noor, what kind of reaction? Very good, Yarin. Noor. So, the sodium ion gained the electron, so it is reduction. We always at cathode area we have reduction. All right. At anode it lost the electron, so it is oxidation. We always at anode area we get oxidation. And they may ask a testing of a halogen here formed or any gas. A testing of chlorine, we use damp red, blue litmus paper, it bleaches. All right, we will revise the testing or analytical later on. Okay, if you have molten but a charge different, for example, this material, you will see it a lot, lead, bromide, or iodide. Okay, so this charge, this two, it will be on the top of a lead. Okay, so I have here a lead positive 2 with sign on the left or in the right. It is the same way. What we write down, ya Abdullah? How to write down the equation at cathode area now? If you have positive 2. Abdullah, how to write down the equation, half ionic equation for 2 marks? Abdullah? By the way, if I ask any student and he repeat not answering, it is better next class don't attend. Yes, we add 2 electrons. What you are waiting for? So we add 2 electrons and we get lead. So the value of the electrons here, it's exactly the value of the charge. Thank you, Abdullah. Then the bromide ion here, I have Br minus. Br minus, I will do the same way as we did the chlorine. So negative 1E, we get Br, we always diatomic, with 2 in front, with 2. What is the observation here for bromine? Reem. What you see, Reem. What you notice at anode area. Brown, Yahya, thank you, very good. Brown, brown. Brown color, bromine, it's brown or reddish brown. All right, that is the molten salt. Let's now repeat aqueous. Aqueous, it's a little bit hard, but you have to memorize this electrochemistry series. This series, it is important, very important. It is the same exactly of metal reactive series, but we have ions here. So positive 1, positive 2, positive 3, no problem. It is just ions. It's called electrochemical series. And we have also for the anion, I have this case, it is diluted salt like diluted sodium chloride. I have another one, forget always the fluoride. I have the same one, but for concentrated one. Pay attention, please. I'm talking about concentrated sodium chloride, and we repeat for other salt to understand. The most important point for me to understand, and then you apply what we do. All right? So what we have here, in the case of concentrated, that means I have a lot of salt, a lot of salt. So a major particle now in this series, enough to memorize this one, chloride and hydroxide. Okay, we have a little bit of water. With this case, I write down only this part, enough for me. Diluted, I have a lot of water dilution. That means we add a little bit of solute or salt with more water. So this particle, it is a major one, and the chloride on the top. Once you memorize that, it will be easy to do the question in the exam. Important, important, I repeat again, question in your syllabus. You will get it, inshallah, in the final exam. Let's talk about concentrated and dilute sodium chloride. We'll do every step together until you understand how to write it down. So, sodium always on the top of electrochemistry series, with hydrogen in the bottom. As you go down, easy to form or to discharge at cathode area. What is the meaning discharge? It loses its charge. It will go faster toward el cathode. All right? If I'm writing now a concentrated anion for concentrated salt, we said here el chloride ion with el hydroxide on the top. If you study that, so it is more than enough to answer the question. So always el chloride will go toward el anode if I'm talking about concentrated sodium chloride. All right? What about the dilute? Always a sodium ion in the top, group number 1, while hydrogen ion in the bottom. So this particle will go toward the cathode area. But we are talking about dilute. What's the meaning of dilute? And instead of Cl minus, OH minus within this chloride. All right? So which particle will go in this case? It is this one. As you go down, an ion will go faster toward each electron. Let's practice together. Please pay attention. I'm repeating that because it is very important question in your exam. Now, I have concentrated sodium chloride. Break down the salt this way. You never forget it in the final exam. So I have plus, minus, or plus, minus. That's mean competition between the sodium ion and the hydrogen. Which particle will go now? Yalla ya Muhammad. H plus, H plus. So the hydrogen plus will go first because it is more reactive in the electrochemistry series. Let's write down the equation at cathode area. So we have two particles compete to each other. Which one will discharge first? So H plus, same way, plus plus 1E. We're not writing in one, please. It is H. But the gas is what? Diatomic. Diatomic. So what we write down in diatomic? 2 in the bottom, with 2 in front, with 2 electrons. Thank you, Salma. It is right answer. What is the observation? What you see? It is just bubbles. Bubbles of colorless gas. El hydrogen is colorless gas. Regarding el halogen, don't worry. When we study periodic table, I will give you the color of all halogen. All right? So, colorless gas. Who remember a test of hydrogen? Yusuf. How to test the presence of hydrogen? Yusuf, Mahmoud? Yusuf, it is grade 9. Yes, very good. Lighted splint, it burns pop sound because it is explosive. But we are not writing explosive. It is just pop sound. This lighted splint. It is splint. All right? Now, I will do the same way for a diluted one. Please study this way at home. Okay? So competition always between hydrogen ion and sodium ion. Never ever sodium ion go toward the cathode in aqueous solution in either case. All right. So I will repeat this equation again. Where at cathode area. At cathode area. Let's write down the equation. 2H plus 2 electrons, we get hydrogen gas. So we get bubbles of colorless gas at cathode area. How to test it? By litmus, splint, lighted splint. It burns with pop sound. Now for a concentrated, we leave now is sodium ion. Let's see later on what will happen. Competition between a chloride ion and hydroxide. Which one in the bottom of the concentrated? Chloride ion. So what we get? We get chlorine gas. We get bubbles of green gas. I repeat, important question. So at anode area, what we get? Cl minus. Subtract 1E, we get Cl, always diatomic, 2 with 2 with 2. Well, I repeat, if you want to write down the electron after the arrow, up to you. All right? So we get here green bubbles at anode area if they ask about an observation. We get two kinds of gases only in this case. Let's see what about a dilute. I have a little bit hard equation. I said just memorize it, but I will try to simplify it for you. The competition now between the OH ion and the chloride ion, what we said about a dilute, which particle will go? OH negative. All right, let's write down the equation together. So I will write down OH negative. I need to get what? Oxygen. So I will write down 4 particles. Just memorize. We have 4 particles. So we subtract how many electrons now? Minus 4E. Very good, ya Muhammad. What we get? We get O2 plus 2 molecules of water. 2 molecules of water. Important equation. We will see this equation many times today. So we get, instead of chlorine gas at green gas at anode in case of concentrated one, we get colorless gas. Don't mention a name. Colorless gas. The oxygen around us has no color. Colorless. So we get bubbles of colorless gas at both electrodes. In case of concentrated, we get colorless bubbles at cathode, but green gas at anode. But we didn't finish this process yet. So we cancel this particle. It's already formed hydrogen. With this particle formed another chlorine gas. What happened now between the sodium ion, Abdurrahman Naim? Abdurrahman Sunusi absent today. So what will happen between these two particles, Abdurrahman? If you have positive and negative ion, what will happen? Abdurrahman? Very good, Yareem. Very good, ya Abdurrahman. You describe that. You may get a question about how is sodium hydroxide formed. You may write down the equation Na plus OH minus. What we get? You add them together, we get sodium hydroxide. It is alkaline solution. We will revise the acid with base later on. So either you said the sodium ion combined with OH ion, or write down the equation, or attract to each other. All right? So we get two kinds of gases and we get alkaline solution. We never get a metal. All right? From what? From aqueous salt above el hydrogen. So we get 3 products. What about a dilute? Let's get back. Okay, Muhammad, I'll get back to you. El hydrogen gun. OH gun, what is left over now? These 2 particles, a salt remain in the container, becomes more concentrated. More concentrated, that's mineral water gun. This material formed, I said just memorize for this year, at cathode area. So this material at cathode area. If they put litmus paper or universal indicator at cathode area, it will turn blue. All right? I repeat again, this question important in your syllabus. If I have concentrated solution, that's mean I have too much salt, so a chloride ion, it will be the winner. It will go first toward the anode. That's the only difference here in this case. So we write down this equation at cathode area with this equation at anode area, and the remaining particle combined together. We get alkaline sodium hydroxide at cathode area. Clear? What about a dilute? A dilute, instead of this part from salt, I have too much water. So we get oxygen gas instead of chlorine. We get colorless gas. Always a hydrogen formed from aqueous solution of sodium chloride. Instead of green bubbles, we get colorless gas, all right? And if we remove this particle from the container, from the electrolyte, this forming what? Oxygen and hydrogen. So this combined together forming our salt again. So we still have this salt. Yes, that is the product. We get hydrogen, oxygen, and sodium chloride salt. All right? It is important question in your exam. A testing of oxygen glowing splint, it relies. A kind of reaction always at cathode is reduction, at anode oxidation. And you have to know how to explain the reason. All right, Shabab? What else regarding this part? We are talking about dilute and concentrate sodium chloride. Let's repeat it with another thought. If you follow the same way, you never forget. It is not a matter of memorizing. Understand what you have here as a particle. You have a question, Muhammad, or you get it now?
It's left
It's
OH. We left
yes,
from it.
yes,
It will
yes,
always be at the cathode.
yes.
This is what is left of the
Exactly. Yeah. Okay, let's do another thought. Let's do a similar one. Well, I need somebody to help me. If I'm talking about concentrated potassium bromide, I have HOH because it is aqueous. I break down plus minus, all right? Plus minus. Always the hydrogen in the bottom والبوتاسيوم on the top. Any metal group 1, 2, 3, 4. I said just memorize electrochemistry series. What we have under the hydrogen ion? Only copper ion and silver ion. Whatever you get as ion, it's above the hydrogen. All right? So always, whatever we have as ion above the hydrogen, it remains. It remains in the electrolyte. We will do this one now. So the hydrogen ion, it is more reactive now in this electrochemistry series. If we compare, if there is a competition now between potassium ion and the hydrogen ion. Regarding this one, concentrated. What's the meaning of concentrated again? Too much salt. Too much salt. So the bromide ion from salt, it is the winner, with OH on the top. So this particle will go toward the anode first. All right? If I'm talking about a dilute one, diluted salt, same salt, I will break down positive, negative, H and OH. So it will be always a potassium ion on the top, while hydrogen ion in the bottom. Well, hydrogen ion is the winner in both cases. But the dilute, what is the meaning? We have too much water. So the OH negative in the bottom, where the Br minus on the top. Always this one will go in the case of diluted one. Well, I will tell you clue about this question regarding diluted one. All right? Let's ask who? مين اللي يقدر يدو this question now? Hannah. Hannah. Hello, ya Hannah. Competition now at cathode between the hydrogen ion and potassium ion. What we write down? Hannah? Hannah? Yes, H plus, excellent. So always the ion in the bottom will go H plus E will get H, but always is diatomic. 2, 2, and 2. Easy, very easy equation. Well, it is a question in your exam, بإذن الله. It is reduction with test of hydrogen. Well, observation. All this question in your exam. Colorless gas or bubbles. The same way here. I will write it down again, no problem. Plus 2 electrons will get H2. Always diatomic. Please don't write any gas as monoatom. All right? So the hydrogen gone.
No.
Now, for the salt competition between an OH ion and Br minus, which one will go? Write down if you know the answer. Which particle will go now? Very good, Yahaya. Let's write down the equation at anode area. Anode, it is a positive terminal. All right? Let's write down Br minus. I will follow my way. If you don't like, up to you. You can write down the equation in the other way. Negative, negative, E. We get Br. Always what? Diatomic. 2 and 2. If you want to write down the electron in the other side, again, it is no problem at all. The most important point for me to get a full mark. I don't like the bad mark at all. Well, I don't like to hear any complaint from your parents that you get bad mark in the school. If you get bad mark because you are not preparing well for any quiz, that is the only point. IG, just study note, solving past paper. That's it. That's it. Practice past paper and read the note. If you have any difficulty in any part already done, or even you are doing, just ask. All right? Now, for a dilute, what we get? Which particle will go now? Competition. Which one in the bottom? OH minus. We write down this equation. So at anode area, we get, I will write down, I'm sorry, it is just memorize this equation. For OH minus, I subtract how many electrons? 4. So what we get? Oxygen plus 2 molecules of water. To remember number of mole of water, we have 4 H's here. So 2 times 2. Okay, this 2 times 2 of hydrogen. Important equation. So we get colorless gas at anode area. Now I need to check what is the material Yarim left over at cathode area. Already الهيدروجين gun والbromide gun. So what we get now at cathode area, Reem? Yes, we get K plus OH minus. Just add them together. We get neutral material potassium hydroxide. Thank you, Reem. All right, that is the product here formed. So we get 2 kinds of gases at cathode or at anode. Bromine, it may be liquid or gas. We don't know, but just we mentioned color because bromine, its standard state, it is liquid. But maybe cell is at high temperature, so we get this material as a vapor or a gas. Now we go now to the dilute. This particle is gone. So what is the material remain now? If you add the potassium to bromide ion, potassium ion to bromide ion, we get what? K plus Br minus. What we get? Potassium bromide remained salt itself. You see difference? Alkaline solution at cathode area. At cathode area. I'm sorry, you have to memorize. At cathode area. But this salt in the electrolyte in the container as a whole. All right? Yeah. Okay. So I just give you a clue here for any diluted solution, and you will not get a different salt. Either sodium chloride, that is the most frequent question. Diluted salt. To remember, dilute exactly as you break down the water, as you do electrolysis of water. If you break down the water by electricity, what we get? We get hydrogen gas and oxygen gas, and the salt remains. So simple. You never forget that. Exactly as we do electrolysis for what? For water. But the concentrated here is part from salt. All right, the same way if we're talking about here diluted sodium chloride. So what we get? Water broken to hydrogen and oxygen. If you didn't get any part of that, please ask. All right, that is important part in your syllabus. Now, let's start with a material or an ion under a hydrogen. What we have? Very, very important question. I'm talking here about a hydrogen ion. I'm talking about a copper ion and silver ion. In this case, if you are talking about a molten, it's exactly same. But if I'm talking about aqueous, let's see. I'm talking about copper sulfate solution, copper 2 sulfate solution. They will not tell you concentrated or dilute. I have a water available here. So always I have 4 ions. All right? That is copper sulfate solution, which they like to ask about it a lot. El hydrogen, it's over here. What we have under el hydrogen? Copper ion. So competition now between el copper ion and hydrogen ion, yeah. Salma Walid, which particle will go? Very good, Yahya. Which particle will go, Salma? Salma Walid, if I have hydrogen ion and copper ion, which particle will go, ya Salma? Yes, very good. In the bottom. In the bottom. If they ask a reason, it is more reactive than a hydrogen ion. All right? Then, you never, ever, this particle, sulfate or nitrate, form a product at anode. So ignore always this part. All right? So always in this kind of salt, I repeat, important question. So competition between a sulfate or hydroxide. A sulfate, yes, it will go toward the anode, but it will not form a product. Please ignore this particle for the moment. All right? So I have here the OH ion will go toward the anode area. We can write down an equation at cathode or at anode. Yes, of course. At cathode, Yahya, how to write down an equation for copper ion. Copper ion. How to write down an equation? What we add here? How many electron add? Haya. Yes. Plus 2 electron, plus. How many electron we add? Same value of the charge. We get copper. Anyone remember color of copper already done in the extraction of metal? Bravo, ya Muhammad. Brown or pink or reddish brown? Brown or reddish brown or pink? Already we studied that in the extraction of copper. Even they cancel the extraction of copper and the zinc from the syllabus, but we need it. I'm not sure if they give a question or no. If your teacher in the school said it's canceled, yes, it's canceled from the syllabus, but they still get question about it.
We need it.
All right, so please study. Okay, what is this kind of reaction? Reduction. All right, and the color of copper and also the alloy of copper. That's mean, ya Ahmed, it is included still in our questions. Even they wrote in the new syllabus, this part it's canceled. I told you I faced this problem last year with Edexel O level. Before the exam, they canceled certain part from each chapter. But I taught all the part to my student and we solved past paper. And unfortunately, they found question in the final exam about the cancelled part. So it is not a big deal to study this just half page in the note. All right? So we get copper metal, which it is reddish brown or brown at cathode area. Observation. We are talking about something to see. All right? Then this copper ion gun. Competition now between an OH sulfate sorry, a sulfate will not form a product. We write down the equation, this equation again. At anode area, I will write down 4OH minus, hopefully. Very good, Yarin. I subtract 4 electrons. What we get? Oxygen gas and 2 water molecule. Thank you. So we get copper, metal, and oxygen. It is very useful technique to get metal, to extract metal. From salt solution, yes. Okay. So, OH gone. All right. What is the leftover now? What is the leftover now? I have this particle and this particle, yellow eye. What do you think they will form? H plus and SO4 negative 2. What do you think we get? Low eye. Or may I ask Shahd? I checked your name, ya Shahd, and you did very well in the quiz. So we get sulfuric acid. Very good. Where are you, Low eye or Shahd? I have this particle combined with SO4 forming what? Sulfuric acid. Sulfuric acid. We get sulfuric acid. All right. So acid formed. What we get? We get copper metal. We get oxygen gas and we get sulfuric acid. I will ask several questions here. I will ask several questions. Anyone remember color of copper sulfate? You studied that last year in the testing. Blue, very good, ya Muhammad. El copper sulfate, it is blue solution. It is blue. Either el ion, el copper ion, when we revise the periodic table, el transition metal ion, it gives the color. We will revise that. So this material, it is blue solution. They will ask you why the color fades out at the end of the electrolysis.
Copper is separated from.
Very good, because the copper ion is gone. Or because instead of getting here copper sulfate, which is blue, what we get? We get sulfuric acid. All acids, they are colorless. I repeat this question again, you will get it in the electrolysis. So if they ask about the color change, we have original salt, it is blue. It becomes paler. What's the meaning of paler? It is not blue anymore. Pale, very pale. Either you write down because the copper ion already reduced or gone or removed from the electrolyte. Either statement acceptable or due to the formation of sulfuric acid. All right? Or they will ask another question. Why the pH value decreases? You remember the pH value for a neutral salt? How much it value? The pH value for a neutral.
Exactly.
Anyone there? Nobody in this group today? It is not very early. It is 7 only, Amir, not 6, 7. It is 7. All right? But what is the pH value for a strong acid? You was my student, Amir, last year. Okay? What exactly? So the pH value decreases. The pH value decreases. A reason here, because a strong acid formed instead of this salt. The pH value for a salt, it is neutral. We will revise that. But this one, the pH value maximum 3. So the pH value decreases. If they ask this question, you know how to answer it, please. Clear يا شباب الكبر sulfate? This is the case of copper sulfate using unreactive electrodes, inert electrode. We will talk about the reactive electrode in a few seconds. Let's talk about the other ion under a hydrogen solution. If I'm talking about silver nitrate solution, also it may be a question in your exam, but they prefer always to write down the copper sulfate question. Silver nitrate, water. Let's break it down as usual. Silver ion, hydrogen ion, nitrate ion, OH ion. I repeat again this statement. We never ever get sulfate we get product from sulfate or nitrate. Never. But it remains in the electrolyte. What we have again, I have a silver ion in the bottom. والهيدروجين ion on the top. We said we memorize this reactivity or electrochemistry series. All right? The same way, we ignore this particle for the first month. Okay? So we understand this particle will go toward the anode. Now, which particle, ya Yusuf, will go toward the cathode area? Very good, Yahya, before I ask the question. Which particle, Yusuf, will go toward the cathode area in this case? Yusuf. Which one? We have two positive particles. That is not the answer. Which particle will go toward the cathode? Quickly, Yusuf. Yusuf? How many times I said that today? Yes, silver ion. Very good. So let's write down an equation at cathode area. A silver ion, it has only positive one. Memorize it, please. Plus 1E, we get silver. With silver, it has gray color. Gray color. So we get gray metal. All right? Even it's called silver. So this one is gone. We said a nitrate never form a product at anode area. So the common equation at anode, I think all of you memorized it now. 4OH minus, we subtract 4 electrons. What we get? Oxygen and water. Excellent, ya Muhammad. So we get silver with oxygen gas. Then, what is left over? A nitrate ion and H plus, what it will form now? Ahmed, what we get remains in the electrolyte? Ahmed. Very good. We get nitric acid. Thank you. So H plus one nitrate ion combined together, we get HNO3. What is this material called? Nitric acid. So same question, and pH value decreases from 7 to 1 due to the formation of this strong acid. But there is no color change here as in the case of copper sulfate. Please revise. Important, all of that. So because of this electrochemistry series, when we do electrolysis for, this is a salt, but if I'm doing electrolysis for copper sulfate, important question. Copper 2 sulfate, I get copper, oxygen, and sulfuric acid remain. Silver nitrate, we get silver, oxygen, and nitric acid remain in the electrolyte. Okay, so we talked today about important salt mentioned in your exam. So please practice at home. Write down the name of the salt or a formula. They will give you usually a formula in the chapter of electrolysis. You break always into ions this way. That is the best way. All right. So we understood now that we can extract metal from either molten or aqueous salt. Aqueous salt under hydrogen only we can get metal. So we can get copper or silver only from aqueous salt. All right? From aqueous salt under hydrogen, any aqueous salt above hydrogen will never ever get metal from aqueous. So if you have potassium ion, you have sodium ion, you have magnesium ion, you have aluminum ion, we never get so metal from aqueous above hydrogen. A reason, hydrogen, it will go first. If you compare which particle will go, always we check where exactly its location in the electrochemistry series. So please, we have only these two salts. We can get metal from its aqueous salt. When we can get metal here, only from molten one. If it is hard, we will practice homework about it. But please study now. All right? What's your question, ya Muhammad?
Miss, in molten we can get metals?
Yes, of course. Molten either under hydrogen or above hydrogen. Let's see one salt under hydrogen. If you get, for example, copper chloride. So we get copper at cathode and we get chlorine gas at anode. Okay? If we get silver bromide, we get the silver at cathode and we get the bromine at anode. If what? Molten. But here I need to clarify this point. Any aqueous salt above the hydrogen will never ever get metal. We get two kinds of gases. All right, clear? Please study. We will revise and we do questions, we do quiz, and until you understand this chapter. Okay, let's talk about important use of other important use, electroplating. We just heard about that. About let's talk about the purification first. In case if we use active electrode, reactive electrode or active electrode, in all these cases we didn't talk about active, it is just inert electrode. The inert electrode we use here in these two cases, it is either graphite or platinum, titanium and platinum only. What is the property of this three kind of material? Inert, unreactive electrode. All right, let's see the question and I will tell you what is the difference to understand. If I'm talking about the purification, we talked about the extraction of zinc or iron, then we get copper. I get zinc, it is impure. That's why, Ahmed, I said just study this part because it's part of electrolysis. All right. Well, I have impure copper also. How to purify that? By electrolysis. By electrolysis. And then I will write down comment about a kind of electrodes in this case. How to fix an impure? An impure metal always ugly shape at anode area. Important question in your exam. Whatever in metal, but because zinc or copper, it is frequent metal in your syllabus, they will ask about it. Even they wrote it's cancer. So impure metal over here at anode, impure metal, impure copper in this case. All right? Well, a small sign of the cell, it is the cathode area. I will fix here very thin layer of pure metal. Pure metal. Well, in this case, I have zinc. All right? This one, it's the cathode area. So you have to memorize that we fix impure at the anode. All right? This important. I will do the same for copper or any other metal. Ugly shape here because it has impurity. Impure zinc, sorry. This, okay, I changed this copper and this is zinc. Okay, impure zinc. At where? Anode area. And pure zinc, very thin layer. We will understand now this point at negative terminal, which is called cathode area. I get here pure what? Zinc. What about the electrolyte? Always we choose in this case aqueous electrolyte. Until you understand the solubility chart later on, I will write down here either aqueous, this important word, aqueous, zinc nitrate, copper sulfate or copper nitrate. Okay, with this way also aqueous, okay, what? Zinc nitrate or sulfate. All right, Shabab, let's understand. Yes, I'm repeating. Okay, we are doing what? Purification of the metal. This part, it is the last step of when we extracted zinc or copper from the ore. I need to get pure metal because after the extraction, roasting, and the reduction, we get impure. What's the meaning impure? It has harmful material. All right, I can't use impure copper to make wire, for example. It should be impure. It should be pure to remove any impurities. So impure metal always we fix it at anode area. Well, pure, they get very thin layer from where it is not our problem at cathode area. And what is the electrolyte? It will be aqueous copper sulfate. Aqueous copper sulfate, or you may write down copper nitrate. We will study later on a solubility chart, because we said I need the ions to be free to move. We never use solid. With same idea here, impure zinc at anode, well, pure zinc at cathode, and then we cover it 2 electrodes with aqueous zinc sulfate. What's the meaning of aqueous? I dissolve this material in water. All right, let's see what will happen. Always the action done at the positive electrode. Always the positive person. A positive person takes the action. We have one equation and you flip it. What is the meaning of that? At anode, anode dissolves, forming ions. So one equation at positive electrode, which is anode, copper, I write down an arrow here. It gives ions, copper plus 2 electrons. All right? I repeat again this step. Well, it is important question. So anode dissolve or gives the ion. Where this ion will go? Toward the electrolyte. Toward the electrolyte. I have only here one kind of ion only in the electrolyte. I have only one ion, even we have copper sulfate. Where this copper ion will go? It will be attracted where? Toward the cathode area. Toward the cathode area. Just flip the equation. Flip the equation. What's the meaning? At cathode, which is a negative, I just flip this equation. So I write down copper ion reduce or gain the electron forming copper metal. It is one equation and just flip it at cathode area. So what will happen now? I get the mass of this cathode increases. We get very good. So the mass of anode increases. We'll talk about this part. What will happen to the anode? Shrinking or decreases. And the dirt or impurities, it will settle down here in the bottom of the container as a material called the sludge. No problem the name, but the impurities will remain over here. All right? Sludge. Let's do the same way for zinc. Same way. At anode, anode dissolves. What's the meaning of dissolving? It gives the ions. So zinc, an arrow, zinc plus 2 electrons. Where this ion will go? Toward an electrolyte. It will move over here. All right? I have zinc ion positive. Always attracted toward the opposite charged electrode, toward the cathode. Flip this equation at cathode area. All right? So negative. So L zinc plus 2 electrons. What we get? Zinc. What happened to the mass again? Increases of cathode. Mass increases. With this one decreases. I will ask here, or you get questions about this part. They will ask to write down if this labeling is not given, just label the diagram. General talking, whatever in metal. I just give example about zinc with copper. If they give you this container, what is the labeling of this one? General talking, this shape, impure what? Metal. Impure metal. It has impurities. Where exactly? At anode area, at anode terminal, at the positive terminal. Where is pure one? This small sign, very thin layer, it is pure metal. Pure metal. All right? And what's my electrolyte? Please don't forget. Always electrolyte cover both electrodes, it is what? Any metal sulfate, but it should be what? Aqueous. Aqueous. We write down these two words, two letters, aqueous. I write down general talking at anode. How to write down the equation? Whatever in metal, M, anode dissolved, forming M positive 2 or positive 1. Why? Because it lost 2 electrons in this case. And then at cathode area, just flip the equation again. So what we have here, M positive 2 plus 2 electrons, we get a metal. You flip this equation, you get 4 marks about that. And they may ask you to labeling. What is the labeling here? You write down what you add here, where you fix an impure metal and where you fix a pure metal. A pure metal, it's very thin layer at cathode, well impure at anode. Important question, minimum 4 marks in paper 4. Now, if they ask why the mass of cathode increases, what happened here? The mass of cathode increase because the metal ion reduces or discharge or forming metal deposited, pure metal deposited at cathode area. Why the mass of anode decreases? Because it dissolves forming ions. You will see this question. All right. So we talked here about the purification of copper. Purification of copper metal. Impure copper always at anode, well pure copper, very thin layer at cathode, and the electrolyte aqueous copper sulfate. Same way of a zinc, impure zinc at anode, well pure zinc at cathode, well electrolyte aqueous zinc sulfate. One equation and you flip it. Always start with the anode. The anode, it's the positive part. All right. So plus, it will form a plus. The anode, it is a positive terminal. It will form plus, it will form a plus. According to the value of the charge. It will be either copper or zinc or silver. We will do silver together now. All right. So this one, it loses electron forming ions, and this ion will go toward an electrolyte. Then it will be attracted here. Okay. So once you see this purification, we use what? Active electrode. Active electrode, because the copper, it's active. All right. It is reactive. It is not like L-titanium or L-platinum. All right. But the question, maybe you read this word or this sentence in the note or your chemistry book. But what is the question? If they said, what is the difference between electrolysis of copper sulfate solution using inert electrode, which is graphite, all right? We know what we get from copper sulfate solution. Copper sulfate solution using graphite or platinum or titanium, which is inert electrode, we get 3 products. We get 3 products. We get the copper metal, we get the oxygen gas, and we get sulfuric acid. All right? In case purification, that's mean we use active electrode. Only we get a metal, pure metal. That is the only product formed here. All right. So if they repeat, or if you get this question, I will repeat it over here to understand. A question simply, they will ask if you do electrolysis of copper sulfate solution, all right, in what? Using inert electrode. Inert electrode, or they will tell you in the question graphite or carbon. What we are talking here about? We are talking about electrolysis of copper sulfate solution in normal way. What we get? We get copper metal, okay, and you get oxygen gas, and you get sulfuric acid. 3 products here for H2SO4. That is the 3 material. If we use this electrolysis, in this case, we use inert electrode. Again, inert here, it is either graphite or platinum or titanium, right? If they said electrolysis repeated, they repeated the electrolysis using what? Copper electrodes. Using copper electrode. So what they are talking about? Purification. Purification or refining. All right, you will see this statement. Electrolysis repeated using copper electrode. What's the copper in this case? It is reactive electrode or active electrode. Or you get a question how to refine or to purify. Refining or purification, it's the same meaning. We remove impurities. So what we get here, impure always at anode, pure metal at cathode. All right, that's pure copper. I have impure copper. We get only one material. We get only copper metal at cathode. Impurities will remain here in the container. It is a question بإذن الله in your exam. Even you notice maybe it's a little bit complicated for you, but if you understand the concept, you will answer it by practicing question. Practice. All right? So that is a purification. We can do purification for silver? Of course. Purification of silver, it's what? Active electrode. So impure silver over here. All right? Well, pure silver at cathode area. All right? So this pure silver, very thin layer. And then I have this one at anode. Well, electrolyte, it's what? We choose here silver nitrate solution or also salvage. What will happen? Anode dissolves iron for silver only +1. Memorize it, please. I get silver ion +1 electron. Where it will go? Here in the electrolyte. With this one dissolves, that means it will disappear after a while. It's shrinking. Its mass decreases. And then a silver ion, where it will go? Yeah. Okay, toward the cathode area. Toward the cathode area, just to flip this equation. This happened at anode, and at cathode, Ag plus E will get silver metal, gray metal. So this mass increases and this mass decreases, for all the impurities remains. All right, hopefully you understand that. Last part in the electrolysis, we finalize this chapter. If you didn't get any part from that, don't worry, we will repeat. It is not last part. In fact, we have still one part more. Here I have electroplating. What is the meaning of electroplating? We studied that as a technique to prevent rust. Important question. You will get plan test. Plan test, that means writing an experiment. That's the last part we do in our exam or ourselves. Okay? We fix an object here, forget all this sign. It is just a small sign. It is the opposite of purification. I will fix a key or an object at cathode area. Right? Assume this is not there. I fix, no need for lamp in this case. All right? So I will fix an object at cathode area. And I need to coat it with less reactive metal. I need to coat this iron key with copper, or even make it silver, for example, or gold, to look much better and also to prevent it from rust. We need to prevent this object to prevent any water or oxygen to attack it. So I repeat again, an object is fixed at cathode area. Well, metal we need to coat with at anode area. Once you studied that, you can write down the two equations easily because it is the same way of purification. What we write down at anode dissolves. Assume I'm doing silver. Silver, it will dissolve, forming silver ion and electron. Where does this silver ion go? In the electrolyte itself. So one equation and you flip it at where? At cathode. This equation occurs at anode area. All right? At cathode, just you flip. At cathode, a silver ion reduced, Ag plus, gain the electron, forming what? Silver. So this key, it's completely coated now with silver. It is for decoration or looks much better, and also it resists the rust. Right? Important question in your exam. Electroplating. What's the meaning of electroplating? We use electrolysis to coat a metal with less reactive metal to prevent it from rust. Okay? You will get this question maybe. It is question in paper 6, minimum 6 marks. You have to know how to draw L diagram. Usually they ask about a key or ring or pen or cup. For always, we fix an object at cathode area. All right? At cathode area. All right? Well, metal we need to coat with at anode area. All right? That's the anode. What we fix? Assume I need to coat this ring with nickel, for example. Whatever they like. Because it is rusted, so we need to protect from rust. And what is the electrolyte? Aqueous salt. Aqueous, this metal. Aqueous nickel nitrate or nickel sulfate. Always one equation and you flip it. So at anode, a nickel dissolve forming nickel positive 2 plus 2 electrons, and then that's at anode area. At cathode area, what will happen? A nickel plus 2 electrons will get here a nickel, one equation, and by the end of this process, what we get? A ring is completely covered with this metal. Okay, well, sometimes we rotate a ring or an object to get even layers. That's mean to be equal coating. And also we have to clean it before electroplating. All right. I know it is a little bit long chapter. Well, it has a lot of data. It is okay. We repeat it. We repeat this always explanation when we practice question. Always, I like my student to solve exam papers. We will see the kind of question later on. Last part about this chapter, it's called voltaic cell. It is just a small part. I know you get bored. I have one student here is kicking every time. You may stand up. Okay? So what we have? Something called voltaic cell. Voltaic cell. Voltaic cell, or sometimes it's called galvanic cell. It is very small part. Unfortunately, they introduced from an American system to British system. It is just 1 page or less. Very short that. Please pay attention. What is this galvanic cell? I will compare electrolysis. I have cell, battery here, connected to 2 electrodes, and so I have here battery. For the moment, we write it down, it's battery, right? Battery. And I have my electrolyte, whatever electrolyte. Okay? In case of a cell or galvanic cell or a voltaic cell, I will draw, instead of the battery, voltmeter. El voltmeter, what the voltmeter do? Measure voltage. Measure voltage. And then I connect also this one to two pieces of metal. Two pieces of metal. Assume this iron and this copper. So that is the first time to see electrodes from different metals, and they are reactive, both. So the difference between electrolysis, it is a question, electrolysis and galvanic cell or a voltaic cell. It is what? What is the first difference? Electrolysis, we have battery. I have here battery from the diagram. All right, I have battery. Here what? No battery. Or there is what? Voltmeter. All right, I'm comparing a voltaic cell. Well, also, they like to ask a lot about it. So electrolysis, there is battery. Now, I have here the electrolyte. Most cases, they add sulfuric acid as electrolyte. But our electrolyte and the electrolytes, it's completely different. Okay? Let's just understand what is going on here. If you have an acid and one metal more reactive than the other, what will happen? A more reactive metal react with the acid, forming what? Forming salt. We revise this later on. We get iron sulfate in this case and hydrogen gas. All right? So what we have here in the voltaic cell or galvanic cell, a chemical reaction produces energy, gives electrical energy. Okay, let's understand this more. So when the reaction gives the energy, what kind of reaction? It is exothermic process. Exothermic process. All right, let's understand why this happening. We have a reaction, one metal more reactive than the other as electrode. So the more reactive will react with the electrolyte. In most cases, they give you electrolyte as an acid. Let's understand that. Let's understand that more. So if you write down this ionic equation for iron react with the acid. Okay, if you break down this one, it forms what? Iron by loss of electrons. By loss of electron. If you break down the salt form. All right. Now this electron will move from this electrode, going from the most reactive one to the least reactive one. So this electron, it's a flow of electron here, it's a current. So we get voltage, we get electricity.
What does
Again, I repeat this equation, not necessary to be iron every time. So the more reactive metal react with the acid. All right. So what we get from this reaction? Electrons given. Where this electron will move? It is from iron or any reactive metal. I repeat this one with another metal. So it will go toward the voltmeter and we get value. All right, very good. So the process, it is exothermic. We said electrolysis is what? Breaking down of ionic compound like sodium chloride by what? Electrical energy, supplied energy, needs energy. So electrolysis is what? Endo. If you get a question in your exam, state two differences between a voltaic cell and the electrolysis. A voltaic cell, it is exothermic, while electrolysis is endo. All right? There is battery in electrolysis. There is no battery in voltaic cell. All right? Let's do the same voltaic cell with other metal. Assume I have here a zinc. A zinc. What I have here an iron also. So which one is more reactive? Is zinc. So a direction of current, it will go from zinc. I have always my electrolyte, sulfuric acid, H2SO4. Write down the equation to understand. Is zinc plus H2SO4, what we get? We get hydrogen gas, all right? And we get zinc sulfate. So let's understand how electrons coming from. By, if you break down this one, is zinc forming what? Zinc plus 2 by loss of electron. So this electron will move. The direction of electrons always from the most reactive one to least reactive one. All right? I just say last statement regarding this chapter. The most reactive one act as a node. All right? The most reactive one in voltaic cell act as a node. I'm sorry, just memorize. Its charge is negative. Its sign is negative. Well, cathode, in this case, it will be the less reactive one. It will be positive. It is opposite to the electrolysis. Electrolysis here, cathode always negative. This sign, it is negative. Well, anode, it's positive. But we don't have this sign in the voltaic cell. How I check an anode? It's a question in your exam. Which road it is the anode? The most reactive one. The most reactive one. And memorize that an anode only in the voltaic cell, it is what? Instead of positive, it will be negative. What about sign of the other one? Positive. All right? So that is the last statement about a voltaic cell. All right? So a three difference here. Anode, in this case, it is negative sign. Well, anode for electrolysis, it's what? Positive sign. All right? So we have three differences here regarding a voltaic cell. We have application for this voltaic cell. It's considered for energy source. For energy source. We'll talk about it later on hydrogen fuel cell. But this part, it is very, very important question in your exam. Well, this is the difference between a voltaic cell and electrolysis. There is battery in the electrolysis. This sign, it's a battery, and there is no battery here. It is either ammeter or voltmeter. It's better to say voltmeter. All right? And it is endothermic process because electrical energy is used to break down ionic compound. Here it is exo because there is a reaction between a zinc and sulfuric acid. There is a reaction between metal, reactive metal and the acid. Okay? And you see direction of the current from the more reactive one to less reactive one. With sign of an anode, which it is the most reactive one, negative sign. All right? So this is the three difference between. What is this part you miss? El voltage value. They will ask how to increase el voltage. How to increase el voltage in voltage cell. Okay? I need to increase the value of the voltage. Briefly, you check a reactive series. If I'm talking about potassium, sodium, magnesium, aluminum, and so on until el copper with silver. All right? If you make it two electrodes, same kind of metal, for example, copper and the copper, what you notice the value? 0 volts. If there is no difference in reactivity. How to increase the voltage? Get metal from the top of the reactivity series and one metal from the bottom. If you increase the difference in reactivity, you get the maximum voltage you want. All right? So if you put here magnesium and the copper, that's the magnesium and the copper distance, it is larger. So we get higher value of the voltage. If you put copper and zinc, where is copper with zinc? Aluminum here, and then carbon, and then zinc and iron. All right. So if you put zinc and copper, you see this distance, it is less. It is less. So briefly, if you increase the difference in reactivity, voltage increases. Very important question in your exam. So copper in the bottom with zinc over here. All right, to get this value. But if you get in magnesium from a reactive series, okay, we studied the reactive series in the extraction of metal. Okay, just to check, I said it's better to memorize it. So I have here magnesium on the top. Well, copper, it is in the bottom. You see this distance? It's called difference in reactivity. By using two metals with large difference in reactivity, voltage increase. This one, it's a little bit closer. And here I have the same metal, so 0 volts. You get that? So question again, how to increase the voltage in the voltaic cell? You choose two metals far from each other. That is the best way. He will give you choices, of course. And we can increase here electrolyte. He changed the electrolyte. Instead of this acid, he put whatever electrolyte, increase its concentration. All right. So how to increase a voltage by in the voltaic cell? By increasing the concentration of the electrolyte, or increase the difference in reactivity of the two metals. All right. I wrote everything for you. There is no excuses to say I didn't study, I didn't understand. Okay, I already recorded this class. I will send the recording to your group, but please study. Next time, inshallah, we'll solve homework. I have here at the end, we have some ions. We will see this example of electrolytes in our past paper questions. Just read it. If we have time, inshallah, next time we may do this part. And also I will give you a voltaic cell. And regarding this table, also for extraction of metal, we do it next time. I know it's a lot today. Please study. Or for the student didn't do the quiz, today is the deadline. Do the quiz and send today for correction, please. There is no excuse, even you have many things to do. Please. It is about an atomic structure, bonding, radioenergetics only. All right? So please, for the student didn't do it, send it today. All right? Thank you. Bye. If you didn't get any part, you may ask. We'll continue this homework next time. Bye. Bye bye, Muhammad. Bye, Yahya. Bye, Ahmed.